So this is the third class on vectors. Like when I say third class, means like rejected some kind of. This is class number 3 for vector algebra. Okay. And then in this class, I think we will continue with our exercise 10.3, which is mainly on the dot product. Dot product, or we call it as scalar product, because why scalar? Why do we call it a scalar product? Because yes, because this product gives us a scalar quantity. Okay. There are two kinds of product in vectors. One is dot product, which we write it as A dot B. And there is cross product, which we write it as A cross B. Here, A dot B, dot product of two vectors, is defined as magnitude of A, magnitude of B, with the cos of the angle between the two vectors, right? Yeah. So here, magnitude of A is a scalar quantity. Magnitude of B is a scalar quantity. Cos of some angle will always give us a scalar quantity, right? It means this entire right hand side is a scalar quantity. Its entire thing is a scalar quantity. That is why we also call A dot B as a scalar product, because it gives us a scalar quantity. We don't call A cross B as a scalar quantity, okay, or as a scalar product. This A dot B dot product can be called as a scalar product, but A cross B cannot be called as a scalar product because it gives us a direction. So A cross B, A cross B will give you another vector, but A dot B will give you only the magnitude. It will give only a scalar quantity. All right. This A cross B we will come to later. It will come later on, not now. So we'll just focus on this A dot B, okay? Which we have learned and which we are again going to learn do more applications on this. Now you see, okay. In vector algebra, if A and B are any two vectors, and if you are asked to find out the product of A and B, then there are two products defined in vectors. One is scalar product, or one is dot product, and one is... There are only two kinds of product defined in vectors. One is dot product, one is cross product. But if you're asked to find out the product of two vectors A and B, then we always go for the dot product. Okay? So sometimes dot product, okay, we take it as ordinary product. So we also call this as scalar product again. So why is it called scalar product? Because its value gives us a scalar quantity, right? Also, the product of two vectors, if the question talks about product of two vectors, then we only go for the dot product. Okay, due to these reasons, this dot product is also called as scalar product. Okay? Okay. Now, I think that is enough for us to know. Okay. From this definition also, we can find out the angle between two vectors, right? Cos theta is equal to A dot B upon magnitude of A times magnitude of B. That is how we can find out the angle between the two vectors also, right? That is one thing. Another thing is, suppose your vector A is x1i plus y1j plus z1k. Your vector B is x2i plus y2j plus z2k. If you are asked to find out the dot product of these two vectors. Then without finding angle theta, without knowing angle theta, you cannot find their dot product, right? According to the definition now. Only if you know the angle between these two, then you can evaluate the dot product, right? A dot B. But see, things also can be done in this way. Instead of using this definition, dot product of A and B can be evaluated easily. How? Your A is x1i plus y1j plus z1. Okay. Dot, what is your B? x2i plus y2j plus z2. Okay. y2j, that is Chris Jericho. So we'll just evaluate their product. We can just simply evaluate the dot product of any two vectors without using the definition. If angle is given, use the definition. If angle is not given, you can just evaluate their dot product without the definition. Okay? And we know that I cap dot I cap is 1, j cap dot j cap is 1, but k cap dot k and k cap dot k cap is 1. I dot j will be 0 or j dot I will be 0. I dot k will be 0 or k dot I will be 0. J dot k is 0 or k dot j is 0. Okay? So the product can be evaluated as x1 into x2 plus y1 into y2 plus z1 into z2. So this is how we can evaluate the dot product of two vectors without using the definition. Okay? We have come across this problems relating to this one many times. Relating to this one also many times, but just we're highlighting. Okay? Now there is one more important thing. A dot B will be equal to 0 under what conditions? A dot B will be equal to 0 under what conditions? If theta is 90 degree. Okay, if theta is 90 degree. That means only if the vectors A and B are perpendicular to each other. 90 degree means it's like plus 10 pi by 2. Huh? So only if the angle is 90 degree, pi by 2. Only then, that means if A is perpendicular to B, then their dot product will be 0. That means if you are asked to show that two vectors A and B are perpendicular, then you evaluate their dot product. Okay? Now simply you can evaluate the dot product, and then if you can see that it is 0, then they are perpendicular. The two vectors are perpendicular. Is it okay? Yes. Or if it is given the vectors are perpendicular, then you can just follow the rule that since the two vectors are perpendicular, so their dot product will be 0. These are some of the derived results from here. Okay? Derived results. Next. Since A dot B dot product is also just an ordinary product, so A dot B will be 0 on the second condition that either A will be 0, either if A is 0 or B is 0. Huh? A dot B is also just an ordinary product. That means A dot B will be 0 only if A is 0 or B is 0. You know, either A is 0 or B is 0 होइले ही ताइजो ना product to 0 होबो न होय. तो A dot B 0 कोइले तो इतु लगा condition भी होबो करे. And इतु लगा condition भी होबो करे. Is it okay? Dot product of two vectors is 0, not only due to this condition or not only due to this condition. It can be any one of these conditions. Is it okay? Yeah, basing on this, there can be many questions given. Okay, I can make any questions here. Suppose if A is 0, if either A is 0 or B is 0, then A dot B is 0. But the converse need not be true. Is it okay? That in that case, we were going to recall all these derived results. First derived result, okay, second derived result, another way of finding the product. So these three results for and the definition, you just keep in mind, okay? Last class, we wanted to solve more questions, so I just gave you the definition, and then we did not discuss much on these derived results. When we work out with the question, we came across some of this, okay? That's the only thing. So, question number 11. I think two of you were just sitting with me. Question number 11 means you are having difficulty. What is that? What is that? Let us see. Show that what? Show that, show that, okay, magnitude of A times vector B. You tell me.
Plus magnitude of B
Magnitude of B
times vector A.
Vector A
Is perpendicular.
Is perpendicular to. It's a long
Magnitude of A
Magnitude of A
times vector B
times vector B minus
magnitude of B.
Same, no?
Yes.
Okay. You want to show that? See, I think this will give you, see, magnitude of A means some scalar. Now, some scalar into a vector will give you vector, right? Magnitude of B means scalar, so some scalar into vector A will give you vector, vector plus vector, vector. So this entire quantity is vector now. Similarly, this entire quantity is also vector. Vector minus vector will also be vector, right? So let's say that this is vector C. This entire thing is vector C. You evaluate this, okay, say this is vector C, this is vector. You want to show that C and D are perpendicular. That means you have to show that C dot D is 0. Clear? And you'll evaluate their product. Let's say how to evaluate this product. I think you got the idea, right? You need to check whether this is going to give us a magnitude or a vector. Okay, see, magnitude of A means scalar. Scalar, any scalar into vector will be vector only, right? Yeah, so this whole is vector. The whole is in vector. So these two vectors, you want to prove that they are perpendicular. Means their dot product will be 0. Okay. So let's find out their dot product. Okay. Dot product means ordinary product we say, scalar product we say, okay. So this one plus, this is one vector. This is one vector. And this is another vector. So I want to find their dot product. So your first vector dot this second vector. This second vector. So this is your second vector. Okay? So if their dot product is 0, if we can prove that, then they are perpendicular to each other. Let us multiply. This is 1, this is 2, this is 3, so this is 4. First one will multiply with 3, right? So magnitude of A into magnitude of A. Magnitude of A square, right? Again, and then B dot B. See, scalar to dot product to Kiko not defined, right? Some scalar dot scalar will be like scalar only. Is it okay? No? So for scalar, dot product has no definition. Is it okay? Dot product of two scalars will be like, will follow the ordinary math multiplication. Magnitude means it's a scalar, right? So scalar into scalar, A into magnitude of A into magnitude of A, magnitude of A square, scalar only. But B is a vector, here B is a vector, so dot product will be defined. So vector B dot vector B. Vector B dot vector B. Okay? Ito 1 and 4, right? 1 and 4. Minus magnitude of A times magnitude of B. Magnitude of A scalar, magnitude of B scalar. In between the scalar, dot product is not necessary, not required. Just ordinary product only. Dot product is an ordinary product for scalars. Then, now B is a vector, A is a vector, so dot product will be defined. So B dot. All right. Okay. Now for this, plus magnitude of B times magnitude of A. Magnitude of B times magnitude of A. And then A dot B. And then A dot B. Minus magnitude of B, magnitude of B, magnitude of B square, and then A dot A. Dot product is defined only for vectors, not for scalars. Yes.
Suppose we consider A plus B, A minus B, then our result will be A squared minus B squared.
Yeah. But see this dot product, no.
There's a
Okay. No, you see, no, what you're saying is true. That can be, it can be done in that way. No, but see how do we find the dot product of two vectors? I'm following that. No, okay. Now you see, what I wanted to say. A dot B is always equal to same thing. Is it okay? Yeah. So in this case we have, what do we have? Magnitude of A square, right? What is B dot B? B dot B? B dot B means magnitude of B square only, right? Minus, this is vector A, this is vector B, and B dot A, right? This is also vector B, this is vector A, this is A dot B, minus magnitude of B square, A dot A, magnitude of A square. A dot A, magnitude of A square. I can show you how. I can show you why comes A dot A means magnitude of A square. Let me show you that. According to the definition, A dot B means magnitude of A, magnitude of B with cos of the angle. So if this is A, this is B with the angle theta in between them, then this is the dot product of the two vectors. Now if I replace this B by A, then there is no more B now. I'm multiplying A and A now. I'm finding the dot product of A and itself, right? Then in that case, magnitude of A times magnitude of A, right? Magnitude of A times magnitude of A, and the angle between A will be 0 degree. So in that case, A dot A will be magnitude of A into magnitude of A, magnitude of A squared. That is a derived result. Okay? Yes. So for any vector, A dot A will be magnitude of A squared, B dot B will be equal to magnitude of B squared, and so on. This is true for any vector. Is that all right? Yes. Just a derived result, okay? Now see, B dot A is always equal to A dot B. So they are opposite. Now, same quantity but opposite. So we will cancel out each other. Magnitude of A, B, magnitude of A, B, B dot A same as A dot B. No? So what do we have here? Magnitude of A square, magnitude of B square. Minus magnitude of B square, magnitude of, are they same? Are they same? So that is equal to 0. Since we have shown that the dot product of these two vectors is 0, that means therefore they are, let me see, they are perpendicular to each other. That is what you wanted to show. That's a really okay, an easy one. All right. Any more? Any more? I think there are more questions to be asked. Okay, okay, okay. So the next question. Yeah, what is the next one? Okay, just give me seconds. Okay.
A dot A is 0.
Okay, A dot A is 0.
A
What?
dot
If
If
yeah.
if A dot B is 0,
A dot A also 0.
A dot A is also 0, okay.
what
What can you say about B?
Oh, what can you say about B? A dot B is 0, okay. A dot A is also 0. Then, what can you say about B? What do you say about B here? Anything that you can think when you're thinking?
Either
Yeah.
no,
A dot okay, A dot A dot B is 0, that is given, right? That is the first given thing.
the
And A dot A is also 0. A dot A is 0 means magnitude of A is A dot A is 0. A dot A means magnitude of A square is 0. Magnitude of A square is 0 means magnitude of A is 0. Right? Magnitude of A square is 0 implies magnitude of A is 0. Correct? If the magnitude of any vector is 0, then that's a 0 vector. Right? If the magnitude of any vector is 0, then that's a 0 vector. I don't know why. In that case, we don't talk about the direction. Because if the magnitude of a vector is 0, then that's a 0 vector. And 0 vector means it can have any direction. Is it okay? Yes. So now here, A dot B is equal to 0 means either A should be 0 or B should be 0. Right? It's given A dot B is 0. That means either A is 0, if not, B is 0. And we have already seen that magnitude of A is 0. That means since A dot A is 0, that means magnitude of A square is 0. That means magnitude of A is 0. And if the magnitude of A is 0, A is a 0 vector. Right? It's because of A being a 0 vector, their dot product is 0. That means B can be any vector. That means. No? Therefore, B is any vector. Kile tai karni result to 0 ho jaise to. To key vector will be result to the result didn't depend on this. The result depends on this one according to the situation. Is it okay? Because since S is 0 vector, to actual 0 result 0 by Jishin. But the result didn't depend on this one, only on this. That means whatever vector B you take also, this result holds now. Okay? It's like very obvious, but we need to express in this way. Because if it comes maybe 2 marks. Any thing that you want to ask here? Any confusion? I think there is no confusion. Very obvious now. A dot A to 0 asido. It means A dot A means magnitude of A square. Magnitude of A square 0 means definitely magnitude of A is 0. Now, magnitude of A is 0 means A is a 0 vector. A is a 0 vector. Because of this being 0, their product is 0. That means B is any vector. Okay, I think it's very simple. Okay, shall I rub out? Okay. Next. Okay, let me just 2 seconds. 1, 2. Okay, done. Here, see when I rub, dot also should not be there. Otherwise, dot product in Nakabi, very dangerous when we do vectors. Okay,
If
which
vector
question now?
13.
Okay, question number 13.
If vector A,
If vector A,
B,
B,
C,
C,
are unit vectors,
O are unit vectors
such that their sum is zero vector.
such that A plus B plus C is
Zero vector.
zero vector. Zero vector. Okay, zero vector means its magnitude is zero. Okay, correct.
Find
Fine.
A dot B
Find A dot B
plus B dot C
plus B dot C.
plus C dot B.
Yeah. Oh, proof ko lasing ito. No, find. Yan, find this value. Find this value. And we do not. Okay. Oh, it's given already. Yeah. Here, see. Okay. There are two given conditions here. All the three vectors are unit vectors, right? Since I'm not going to write any sentence, okay, but in examination it's very important for you to write. So let me start my solution. Since A, B, and C are unit vectors, so each of their magnitude will be equal to 1, yes or no? Because unit vector means a vector of magnitude 1. Okay, each of their magnitudes will be equal to 1. That is first case. It is from the first given condition. There is another given condition. If you add all the three vectors, then it will be equal to your zero vector. Zero vector means magnitude 0. What I'm going to do is, from here I'm going to evaluate this. So from this expression, how will you get this expression? Only one option. Squaring both sides. Squaring both sides. If I square both sides, vector A plus vector B plus vector C holding square is equal to 0. You cannot use the identity here, okay? A plus B plus C holding square. A plus B plus C holding square means, can I write A plus B plus C dot A plus B plus C? Right? Correct? So let's evaluate this dot product. Okay? So shall we? A dot A plus A dot B plus A dot C. This is done. Now for this B vector. B dot A plus B dot B plus B dot C. Correct? Plus C dot A plus C dot B plus C dot C is equal to 0. Square was 0, right? Now, this implies A dot A means magnitude of A square, right? We have derived that one. A dot B is equal to B dot A, right? A dot B is equal to B dot A. So A dot B plus B dot A, 2 times of A dot B, right? Now, A dot C is same as C dot A. So A dot C, just differentiating them, okay? So A dot C plus C dot A, twice of C dot A. I'm writing C dot AY because that's what I need in that way, right? Instead of A dot C. Again, next we have B dot B. B dot B means magnitude of B square. Magnitude of B square. This is done. B dot C plus C dot B twice of B dot C, correct? Plus C dot C, magnitude of C square equal to 0. A, B, C are unit vectors, so each of their magnitude is 1. So 1 square plus twice of A dot B plus twice of C dot A plus twice of B. Oh my god, what I'm doing here? Okay, this is 1, right? Twice of A dot B, twice of C dot A, plus 1 square, right? Plus twice of B dot C, plus 1 square is equal to 0, correct? 1 square plus 1 square plus 1 square, 3. 3 plus, if I take 2 common, then A dot B plus B dot C plus C dot A is equal to 0. So that means A dot B plus B dot C plus C dot A will be equal to minus 3 by, it's done, alright? You can ask what? The ones which you cannot do, you can ask. The ones which you feel like you are able to do, then it's fine. Okay, next.
This one is about justifying the answer.
Yeah.
Is
Yeah.
is 0.
Uh,
A dot B is 0.
yeah.
But converse need not be true.
Okay. Question number 14. Question number 14 says, if A is 0 or B is 0, question probado, if either A is 0 or B is 0, if any one of A or B is 0, then definitely A dot B is 0. And that's what the question says. Okay, no problem. No argument here. Okay? But no argument here means like I'm not talking about argument of complex number, okay? English argument.
Converse need not be true.
Oh, but the converse need not be true. But the converse need not be true. Converse need not be true. What will be the converse? If A dot B is 0, then it's not necessary that A is 0 or B is 0. It's not necessary that A is 0 or B is 0. That's what they are saying. Okay, you have to show that one. No. If the converse is true means, if A dot B is 0, then either A is 0 or B is 0. If the converse was true. But they are saying that converse need not be true. It means if dot B is 0, then it's not necessary that A is 0 or B is 0. So in order to show that the converse need not be true, you need to justify by giving an example. Means A to non-zero vector italobo. You take B as another non-zero vector, and their dot product should be equal to 0. Okay? Yeah. Now see why converse need not be true. Why is that? Actually, that's a thing to be thought about. Converse need not be true. Why? Very simple. If the dot product of two vectors is 0, then it's because of two conditions. Either the angle between them, that means if Okay. If the dot product of two vectors is 0, that means it's because either A is perpendicular to B. That can be one of the reason, or else A is 0 or this is one of other condition. Now, it's not only because of this condition that this result holds. It's also because of this condition this result also holds. Now, itulah condition. Currently, it result is true. No, for this condition also the result is true. So for this thing, it can be any one of them. Is it okay? That is why converse will not be true. Are you getting me? So you can take certain, you take A as a non-zero vector, since converse is not true, and you take B as any non-zero vector, and you find out their dot product, and it should be equal to 0. Okay? Yes. You got it? No? Itulah reason to itu kan? Yes. No? Okay. Next.
Next one is about a triangle.
A triangle. Okay. Okay. I can just take a textbook. If the vertices A, B, C of a triangle are given, coordinate of the vertices are given, find the angle ABC. Find the angle ABC. The vertices of A is given to be the question number, how much is that? 15. Question number 15, we have ABC are the three vertices of a triangle. A, B, C. We have to find out angle ABC. This is your angle ABC, right? Yeah? This is what we have to find. Now see. This angle ABC is the angle between which two vectors? This angle is the angle between which two vectors? AB or BA? No, it cannot be both. Angle is measured
From tail to tail.
only two vectors are joined tail to tail. So this angle is the angle between the vectors BA and BC. Is it okay? Yes. So in order to find out angle ABC, we need a definition. Yeah, angle ABC means the angle between vector BA and vector BC. So according to the definition of dot product, let me write the definition. Okay, cos theta, now cos theta is equal to vector BA, yes, vector BA dot vector BC upon magnitude of BA times magnitude of BC. Is it alright? Yes. Now what is your point A? The coordinate of A is 1, 2, 3. 1, 2, 3. Coordinate of B is minus 1, 0, 0, minus 1, 0, 0. And the coordinate of C is 0, 1. So first of all, you need to find what is vector BA, what is vector BC, and then you find its magnitude, right? Yeah? Right? So how do you find out vector BA? How do we find out vector BA? Position vector of A. Na ito sa do coordinate system di panay na position vector B halibulas do. So how do we find vector BA? Position vector of A. How do we write position vector of A? What is position vector? Position vector means it's a directed line with O as the initial point and your point to be the terminal point, right? So position vector of A means vector OA. Position vector of B means minus vector O. That's how we find it. Okay? And if the coordinate of A is 1, 2, 3, then the position vector of A will be I cap plus 2j cap plus 3k cap. If the coordinate of B is minus 1, 0, 0, then the position vector of B will be minus I cap plus 0 j cap plus 0 k cap. And and if the coordinate of C is 0, 1, 2, 0, 1, 2, then the position vector of C, vector OC will be 0 I cap plus j cap plus 2 k cap. Is it okay? So knowing the position vectors, you can find out vector B, I1 BC. Vector BC means position vector of C minus position vector of B. Right? Since you have obtained the vectors B and BC, you also find their magnitudes, right? Magnitude of BA, magnitude of BC, and then you evaluate. So theta will be given by cos inverse the whole of this. Okay? After you substitute the values. Alright? Yeah.
And again, 16 and 17 draw easy, no?
Oh, you can try it. You can try it. It's no harm.
One is
Okay.
collinear.
Okay. Okay. And one is collinear, and the other one is vertices of a right angle triangle. Okay. Now you can proceed.